Okay, here's a revenue problem from your Chapter 3 practice problems in Quadratics. A company sells a certain item for $15.75, and at this price, the store sells an average of 2170 units per year. A market analysis determines that for every $3.15% increase in price, the company should expect to sell 70 fewer units. What's the maximum? That is a key word. What is the maximum annual revenue the company can earn if they decide to raise the price? And what is the new unit price? So with a quadratic word problem, as soon as you read maximum, hopefully you clue in that you're looking for your vertex. And if this is a quadratic that has a maximum value, and of course it also has to open down, which is something to keep in mind. Okay, so how do we find that maximum value? Well, that's going to be hard to do unless we piece together a function here. So let's look at it. We have some revenue situation, and revenue is just simply the amount of money that this company is taking in. And right now that amount of money is going to be $15.75 multiplied by 2170. That's at the current price with no price increases, and the average I guess annual sales there of 2170. So maybe we'll have a look at that. And our GDC. Okay, so currently that revenue is going to be, with no price increases, $15.75 times 2170. So all I'm doing here, of course, is taking the unit price times the number of units that I can expect to sell. So maybe we can do this all with our calc. If I go ahead, or if the company goes ahead and says, you know what, we're going to increase that price by $3.15, which of course is $18.90. If we're going to increase that by up to $18.90, so I'll type this in again. What's our revenue going to be? Well, keep in mind we're not selling 2170 anymore. We're going to lose 70 items. Of course, we're only going to sell 2100 items. And we can see that our original revenue did actually increase. Even though we lost 70 sales, our price made up for that lost sales. And we have a revenue now of almost $40,000. And so you can see here that, of course, the number of times that we increase, so I'm just going to put a 2 here, and hopefully not with a plus. Let's double that up. So if we actually increase the price up to $6.30, of course, that's a pair of $3.15. We're going to now lose a pair of 70s as well. I think this gives you a pretty good indication that I guess two things: what our revenue function is going to look like in this situation, and also that our revenue seems to still be going up and up and up a little bit with 2 price increases at least. So notice all this is the new price and then adjusting for the loss of sales. And we can see that our moving part seems to be this 2 that was here. It starts off with a 1, goes up to a 2, and maybe one more just to illustrate that if we chose to go with 3 price increases, or I guess we're roughly $10 at that point. Well, I guess $9.45 if you're keeping score, and we'd lose 210 sales. And our revenue still has crept up a little bit more now to $50,000. So I think that should be enough to piece together a revenue function. And maybe to be clear, we'll also pick X as our variable because we're going to use our GDC here in this paper 2 question. Be clear that X is the number of price increases. Okay, so our price was $15.75, and we know we're going to increase this. The company has decided to do that. We just don't know how many of those increases are going to give us our vertex, our maximum revenue. So for every price increase, we are going to lose 70 sales from our starting point of 2170 sales. So all we have here are 2 numbers multiplied together, and the first one is of course going to be our new price, and this is going to be our adjusted sales. We'll just call it number of sales. And of course multiplying those gives us our total revenue. Okay, so let's find our vertex with our GDC. There we go. Okay, so if you're not in function entry there, remember that's under menu. And then number 3, graph entry, select function. So let's type in our revenue function. checking. Oh, that should be a plus. Otherwise, our price wouldn't increase. And here's our revenue function. Now, of course, it looks like a vertical line right now, but it does look like it should be a quadratic with a pair of binomials multiplied together there. So remember, instead of tinkering around with their window settings much, let's rely on our zoom feature. And we'll go zoom fit and fingers crossed. And look at that. We didn't even need to cross our fingers. So probably just zoom out a little bit more, or if you're able to, use the little hand grabber tool and pull that, scale your axes so you can see your vertex. And we can see an opening down quadratic that of course has a maximum value somewhere here. Well, exactly where is it? Let's use our trace feature, graph trace, and we can walk around until maximum pops up on the screen. Of course, I'm using my arrow keys there. Hit enter, and there are the coordinates of your vertex. Escape. Okay, now this is rounding, and it's also to 3 sig figs, which is actually going to work perfectly for an IB assessment. So we can say 7.14 times 10 to the power of 4, or move your decimal place 4 places, is going to be your maximum revenue. And of course, x equals 13 is the location of that maximum revenue, and that is our x value. So let's make sure we interpret that correctly. So our vertex is, and maybe we should do a sketch here, which is not a bad idea. If this was an IB assessment, so just a very quick sketch, something that resembles a quadratic. So our revenue function looks something like that. Barely qualifies as a quadratic, but our vertex was at 13 and 7.14 times 10 to the 4. So I'm going to write that as 71. So remember, 4 decimal places move, of course. 71,400, and that of course is our max revenue. So that should be enough work to show. You recognize, you're telling the IB examiner or myself that you used your GDC, you found your vertex, and you know that that Y value is your maximum revenue. So we answer the first part of this question. The max revenue is approximately, we'll just say 71400. That has been rounded to 3 sig figs. If you want to use the exact number, you can use that as well, rounded to the nearest dollar. And the unit price, or the new price, I should say, I don't say 13 here, so we have to properly interpret that. $13, of course, times something is not going to give you this maximum revenue. Remember that 13 corresponds to your X value that's in here. So that's going to be 1575 times plus 3.15 times 30. So I'll just scribble it here, and then we'll check that on our calculator, of course. So our new price is going to be 1575 with 13 of those $3.15 increases. So let's just go back to our calculator here. So 1575, X is 13. That's 13 increases of $3.15. Drum roll, the new price is going to be $56.70. And clean this up a little bit. Okay, so that's that. Have a look through that, and if you have any questions, of course, you'll be able to ask me via Schoology.